Aquifers Part 3. So this portion of the lecture, we're going to take you on a tour of a couple of different types of aquifers. For this portion, Part 3, we're going to be looking at the unconfined system. Now, our exploration of the unconfined system is going to start with a journey to one of the to Nebraska, the Cornhusker state. I'm going to zoom way out here just to give you a sense where you're at. Here we are, Nebraska. There's Iowa. There's the Colorado Rockies. This whole region is actually, as we learned during our mountain building lecture, is basically sediment that has eroded off the Rockies since the Laramide orogeny, when the Farallon plate was subducting at a very shallow angle. So as we zoom in, we're going to see if we can spot the aquifer. We're now at an eye altitude of about 150 kilometers. It's still pretty high up, but you might start to see some interesting pictures in the center of this image. See if you can spot it. Oh, yeah. Yeah, I should be able to start seeing here. Oh, some evidence of an aquifer. Somewhere around here is the town of Ogallala, but right now we're about to fly into Alliance, also famous for Carhenge. And the other excitement. So as we fly in here towards just east of Alliance, we see we are flying atop one of the largest aquifers in North America, the Ogallala. And in this section, it's basically acting as an unconfined aquifer. So you're seeing a number of ponds at the surface. We'll zoom in a little more. Yeah, lots of ponds, but no little creeks connecting. In fact, some of these look kind of stagnant. No creeks connecting them. And clearly some water being drawn from underground. We can see quite a bit of wells. Notice, by the way, the surface seems a little bit drier around these little circular irrigation ponds. That's probably telling us something. Notice as we keep heading further east, it starts to get a little bit wetter, a little bit greener. We start seeing things that maybe resemble streams picking up in some of these areas. There's one. Can't really tell if it's the wind. Oh, there we go. Do we see it? Oh, yep. There we go. There's the green space. So there we go. We have a little creek that sort of starts right here in this sand dune. And it's teeny tiny, barely has any water. In fact, I'm not even sure if there is any water in it. Then suddenly it grows to a much larger and larger creek, picks up, joined by a tributary, starts to get some water in it. As we keep heading further and further east, it starts to show more regular occurrence of water, more regular flow. Start getting more of a regular flow, and then here around Dunning, we have a full-fledged river suddenly popping up, and there have not been a lot of we have not in this point till this point seen a lot of rivers joining. In fact, you haven't seen a single tributary join this creek except for that one just at the last spot there, that spot. So what the heck's happening? What are we looking at? So to understand that, we're going to now next go into our little whiteboard app. Introduce some terms. First, this is going to be aquifer, a geologic unit capable of storing and transmitting useful quantities of water. So to better diagram this, we're going to start with the land surface. Make it sort of gently sloping. Put some vegetation on the land surface. Then we're going to use the finer color pen to denote some rock layers. Going to try to draw these as straight as possible, but drawing a straight line was never my forte, so. And we're going to label cup these units. So this upper unit is going to be sort of sandstone. We'll denote that's a sandstone by putting a lot of funky little dots in it. As you can imagine, sand or sandstone has lots of spaces between the pores. So, oops, that one. So, it is going to make a good aquifer. Below this, we're going to put a something a little bit less permeable. We're going to put some kind of shale. In fact, this is going to be quite a bit less permeable. So less permeable that we're going to call it an aqua tard. Just going to color it in gray to kind of get it all, just because it's going to be some clays. There we go. So this aquifer is supplied with water by a process known as recharge. What about the blue pen here? Make it rain. Yeah, make it rain. So this recharge is going to send water into the aquifer like so. And what's going to happen is at some point, these pore spaces are going to start to fill up with water. And you're going to get some portion where all the pore spaces are filled up with water. Right. Yeah. So this sort of zone of the aquifer that's saturated. Um, the actual label this the saturated zone. And above that, of course, is the unsaturated zone. That boundary between the two, we're going to call we are going to call that the water table. Now, in an unconfined system, your water table is also the hydraulic head at your water table, or the elevation of your water table is the hydraulic head aquifer. Water channel. So, water is going to enter the water aquifer through recharge and continue to flow through the aquifer. You might notice this water table is intersecting the surface. What do you think is going to happen to the surface? It's going to be come up in a little bit of a spring. I'm going to put a little spring up here. The springs you see that people get the water out of, and in honor of today being St. Patrick's Day, we're going to make it green to make it an Irish spring, like the soap. Yes, which also hopefully you have plenty of that right now as well. And this is how water sort of leaves the aquifer. Of course, we also have water going somewhere else. This aquifer right now goes on go theoretically forever, but all those places where we saw the river just growing in magnitude, the river was being fed by the water table. And that's because the river is at the water table. There's all those ponds you saw up there on the western part of the aquifer were all probably recharge points, supplying water to it. Remember, I showed you that spot where there was that beautiful circle shaped farm field? Let's see if we can find that again. Just head back there. Sure, we can find a couple of these. In fact, it's this fly throughs on Google Earth never get old for me because I see new things every time I go there. You might notice there's kind of this interesting relationship between where we have these circle-shaped agricultural farm fields and where we don't have lakes. And there's sort of a larger patterns clearly some low-lying spots that are close to the water table than others. But I'll argue that pumping the groundwater in these regions is probably drawing the water table down a little bit. And so you're seeing fewer lakes and ponds, or at least they're kind of drying up a little bit faster right around these wells. Well, in case you're looking at it, we are. Yes, right around these wells. Wells, where are they? Oh, there's one. Yeah. Yeah, you might just see just a little bit less water here. Some of these wells might be sucking the water down a little bit in the area around them. Now, what's this going to look like back on our diagram? Ah, well, it helps that I don't draw with a steady hand, and so we're going to put our well right here. Wow, this is a really big well. This well is going to draw down the water. You're going to get a little cone of depression in the water table. It's going to cause some of the water, especially near the water table, to actually flow backwards towards the well. So the way the well works is you have a pump that's lowering the water pressure in the well, water pressure, so that the water around the well flows towards the well, and then you can extract water from the well and bring it to whatever you're trying to bring the water to. So fundamentally, this sums up what we call an unconfined aquifer system. In the next video, we'll look at confined systems, and then in subsequent videos, we'll look at problems facing aquifers and karst systems.